Alright, question 7. The diagram below shows the positions of 4 players. Player H is due east of player G. That's why we know that if H is due east, north, south, east, west, east, that means this must be a perfect 90 degrees to north, right? And then it also says that the distance between player E and H, 45 meters, okay. Distance between player F and G is 30 meters, okay. EHG is 20 degrees, and the bearing of player F from G is 240, so they actually didn't label this one, so we should label it. Bearing of player F from G, so from G, we go to player F, is 240 degrees. And the bearing of E from G is 15 degrees, and so they also didn't label that one for us, so let's do it. And I'm just going to construct this line right here, right now. Okay. And it says the bearing of E from G is 15 degrees. So that tells me of E from G, that means this must be 15 degrees. This angle. Alright. Cool. Now let's calculate the distance between player E and player G, which is actually the length of the constructed line. E and G, this length. So let's try to find it. One thing we do know is that this triangle is not a 90 degrees right angle triangle, because this is not 90 degrees. Right, 90 degrees is all the way to this line, the north. You're not starting from the north, you're starting from this E. Okay, but if we look at this triangle, we can see that this angle over here, would you agree that it's basically 90, subtract away 15, you get this? Right, and so this really is just 75 degrees. And if we see that, then we can take a look and see that we can apply sine rule. So, but let's just calculate officially the 75 degrees first. We can say that angle EGH is simply 90 degrees, subtract away 15, which is 75 degrees. And then now we can apply sine rule, where we can say that 45 divided by sine 75 equals to EG divided by sine 20. And so we can write that down. And we can cross multiply. So actually we just multiply this over. So we can get EG is basically sine 20 times 45 over sine 75. Yep. So EG is basically 15.9338 if I give 6 significant figures, or 15.9 if I give correct the 3SF. Yep, and it's in meters. Because, yes, they gave it in meters. Alright. And right now, let's find the distance between player E and player F. So, okay, so we're looking at this now, E and F. Alright. And so right now, if you want to look at EF, I'm just going to draw this triangle. So EF is basically this. And the key to finding it is to look at this triangle. Right? And if I can find this angle, FGE, then actually I already found EG, right, which is 15 point, from the previous part, 15.9338. Right, this is 15.9338 meters. And I know that this is 30 meters. I know the angle in between. I can use cosine rule to find EF. But first I need to find this angle all the way here, FGE. And I know this is 15, so actually I can find FGN first. FGN, let's find that first. So we can say that angle FGN is first 360 minus 240, which is 120. Right? 360, which is a whole circle. Subtract away 240, I get FGN. But that only is one side of the story, because this is 120, but we're not looking at this triangle, right? We're looking at this triangle. So we need to find this angle FGE. E. And so we need to take 120 plus 15. And so what we do is we say FGE is 120 plus 15, which is 135. Cool. And so right now we basically have this triangle, where this is 135 degrees, this is 30 meters, and this is 15.9338 meters, and we're looking for this length. Apply cosine rule. EF, because this is EF, square, equals to 30 square, plus 15.9338 square, minus 2 in this cosine angle in between, and if you take a square root, you see that EF is basically 42.7773. If I put it to 6 SF, which is 42.83 SF. Yep. And right now let's look at the bearing of player H from player E. So from player E, so that means from player E we construct a north. All norths must be parallel to each other, alright? And then of player H from player E, so that means we're looking at this. H from E, we're looking at this angle. And how do we find it? Actually the key is also to construct another north right here. And because if you see that this is north, or should I say this is north over here, and this is 90 degrees, and this is a perfect 90 degrees, a perfect east. This is north, that means this is also 90 degrees, right? Because this is a perfect east, 90, 90. And so that tells me that it is also 90 degrees, and that means I can find this angle. What do we call it? Okay, let's call this N2, and let's call this N3. And so we can find EH N3. Angle EH N3 is simply 90 minus 20. Oops. Which gives me 70 degrees. So that means this is 70 degrees. And if I just look at this part, right, these two norths are parallel to each other. So these two, 70 and whatever this angle this is, they are interior angles, right? So you can say that angle N2 EH equals to 180 minus 70, 110. And the reason being interior angles, 110. Yep. So this is 110. Cool. All right. Player G now runs towards player H. Find the distance from E where player G is nearest to player E. So G runs towards H. Let's look. G runs towards H. Okay, nearest distance the distance from E where player G is nearest to E. So basically we're looking at if this guy from G runs to H, at some point he will be closest to E, and that's when we drop a perpendicular over here. And the question is actually saying find the distance from E when player G is closest to E. And so it's closest to E when if you draw a perpendicular from E, right, this is the closest, and so we're trying to find this distance. Cool. And so really it's a bit complicated, but if you look at this triangle, then we see that it's actually quite simple. Let's look at this triangle. So I'm going to say, we're going to call this part where he dropped down X. So really, we're looking at this triangle, E drop down to X, right, and H, where this is 20 degrees. And if you drop perpendicular, that's 90 degrees. And we're trying to find this, EX. And from here to here is 45 meters. So that simplifies things a lot. You can see that we just have to apply our simple trigonometry, and so we can say that sine 20 degrees equals to opposite, which is EX, over my hypotenuse. And so EX equals to 45 sine 20. Yep. And that simply gives me 15.39. If I give 4SF, 15.4. Yep. And now for the last part. Player E throws a ball vertically upwards to a height of 34 meters above the ground. This should be above. Find the greatest angle of elevation of the ball from player G as he runs from his original position to H. So player E, now above here, he throws up a ball, and you want to find the greatest angle of elevation. So the greatest angle of elevation is when this player G, he runs, when he is closest to E, which actually is when he is at X. So basically, the angle of elevation is greatest when he is at X, because he is closest to E when he is at X. Angle of elevation is higher when you're closer, and lower when you are further. And so, since it's 34 meters above, we're looking at this triangle, really. So, okay, let's call this point at E, where he threw the ball above, let's call it E top, okay? So from E, if he throws it up, it goes to E top, right? And that's just going out of the paper over here. E to E top, which I can't really show, but it's above the paper. And then we have this line which goes down to X. So I'm going to construct it this way, from E top. It goes down to X. And this is from EX, is basically what I calculated here, right? EX. 15 point, let's put 39. And then this closes up the triangle. And I'm trying to find the angle of elevation. Yep. And they say that the ball vertically is 34 meters above. So what I can do, I can say tangent, right, of the angle, let's call it E top XE, which is basically this angle, E top XE. Tangent of this angle is opposite over adjacent. Yep. And so that gives me angle of elevation to be 65.6 degrees. Done.